Hello everyone, and welcome to part 17 of the GT Improvement course. We are going to jump into algebra in a second, but before we do so, I have some problems here that I would like you to solve. First four, change these to decimals, change these to percents, and then change to fractions and reduce if possible. All right, so go ahead and pause your video and the answers when you come back. All right, here are your answers. For number 1, 0.9, number 2, 0.07, number 3, 0.375, number 4, 4.45, for number 5, 45.2%, number 6, 60%, number 7, 5%, and number 8, 478%. Number 9, 7/10, number 10, 29/50ths, number 11, 1/100th, and number 12 should be 2/3. All right, so hopefully you did well on that. Let's jump into algebra. Really, we're not going to get super complicated with algebra. It's just some basic principles that we just want to review real quick. So with algebra, the goal is to isolate the variable, usually x, but it can be n or y or whatever. All right, so when you have an equation like this, 3 plus x equals 8, the goal is to get x on one side of the equation, on one side of this equal sign, and then to get all the numbers on the other side. So to do that, we're going to be moving stuff around. And the number one rule with algebra is whatever you do to one side, you have to do to the other, okay? So to get to x by itself, I need to get rid of this 3. So I'm going to move it to the other side by subtracting it. And the reason that I'm subtracting it is because I'm essentially turning this 3 into a 0, okay? And because this is a positive 3, by subtracting 3, I turn it into 0, so it cancels. So you're left with x equals 8 minus 3 is 5. Okay, I know you can do that in your head, but just to review the algebraic principles of doing this stuff, okay? All right, if you add this one with subtraction, so we want this x by itself, we need to get rid of this 7, so I'm going to turn it into 0 by adding 7, but whatever I do to one side, I have to do to the other. So this cancels. I'm simply left with x on that side of my equation, and 13 plus 7 is 20. Okay. For number 3, when you have a number and a variable next to each other, the operation that's happening there is multiplication. This 7 is being multiplied by x, okay? And in order to undo multiplication, we have to do the opposite of multiply, which is divide. So in order to get rid of this 7, I'm going to divide by 7, okay? And whatever I do to one side, I have to do to the other. So the 7s cancel out. Now with division, 7 divided by 7, well, that's not 0, that's 1. So essentially, you're just left with 1x. But we don't usually write 1x, we just write x. So it would be x equals 3. Okay? Number 4, Number 4, same situation. I need to get rid of this 8, and in order to undo the multiplication, I am going to divide both sides by 8. 8 divided by 8 is 1, so we're just left with 1x. 32 divided by 8 is 4. Okay? Number 5. All right, so we have a fraction attached to our variable. No big deal, it's the same process. We are multiplying the half times x, so I'm going to do the same thing. I'm going to divide both sides by a half. So this cancels, you're left with x equals, well, 6 divided by a half. Let's talk about that. 6 divided by 1/2. The rule for dividing fractions is keep, change, and flip. So to turn this whole number into a fraction, I'm just going to put it over 1. And I'm going to change my division to multiplication and flip my second fraction. Now, essentially what I just did is I just turned 6 divided by a half into 6 times 2. So good thing to remember, if you're ever dividing a number by a half, really all you're doing is just multiplying it by 2. And 6 times 2 is 12. And that's your answer. All right, okay. Let's do these ones. For these ones, where you have a number and then a parentheses, the operation that's happening between this 3 and the x minus 7 is multiplication, okay? So what we get to do is the distributive property in this situation. So I don't know if you remember that, but we distribute the 3 through multiplication to each of the numbers on the inside of our parentheses. So 3 times x is 3x. 3 times a negative 7, and we're going to talk more about integers and multiplying positives and negatives later, but a positive 3 times a negative 7 is going to be a negative 21 equals 21. Okay? All right. Now, I am going to have to deal with this in a minute, but the first thing I'm going to do is I'm going to move over this 21 to the other side, okay? Trying to get the x by itself, but I'm going to get rid of any extra stuff first. So by adding, we can get rid of that. You're left with 3x equals 42. Divide by 3, divide by 3, and I believe it's 16. Let me just double check. 1, 3, 1, 14. Right. So x equals 14. I'm just going to circle these other guys. Okay. All right. Final one. So 2x plus 8 equals 26. First thing I'm going to do is get rid of the 8. I didn't mean to write an equal sign. That goes away. You're left with 2x equals 18. Divide both sides by 2. 18 divided by 2 is 9. All right, so those are just the basics of algebra. Here are some problems for you to do on your own. Go ahead and pause the video and complete these, but real quick, for number 14, you're going to get an answer in a fraction. I'm just going to hint that to you now. Make sure you changed it into a mixed number if you can. Okay? Good luck. All right, here are your answers for those practice problems. For number 1, you should have gotten 18. I'm sorry, for number 10, you should have gotten 18. 11 was 42. 12 is 4. 13 is 108. And 14 should have been 1 5/9. All right, so hopefully you did well on that. In our next video, you're gonna see why I'm refreshing you on this, because we're gonna talk about percent of a number. And I'll see you there. Have a great day.